Alright, so here we have the economic distribution model that I designed. Um, Looking on the Google Colab file, the second to last bit of coding, Python, is the building up to the live happens function. And this is just something good to know before or after you look at the other videos describing it. So going through the variables one by one, we have alpha, which is the degree of democratic corruption. It goes from 0 to 1, a variable, right? In up to the reader to choose. When voting happens, it is the individual's amount of money divided by the total amount of money in the society. This is a fraction. Raised to the power of alpha is the weight of the individual's vote, right? So then, if alpha is 0, then all of these fractions will equal to 1, because anything to the 0 is 1. So everyone's vote would be equal. So with 0 democratic corruption, everyone's vote is equal. But if this is 1, everyone's vote is directly correlated to the share of wealth that they own. So now we have beta, which is simply the P in a binomially distributed group out of the 1,000 people. This is K because I thought a C was improper, but it stands for consumers. And that would be the number of people that, given that you're lucky enough to be a producer in a given round, would buy your product. Price of the product is inversely related to beta, because more people buy less expensive products and less people buy more expensive products. And then the third variable, we have lambda, as one might presume. It corresponds to a Poisson distribution, and the Poisson distribution is the event that you have some sort of entrepreneurship opportunity, i.e. you become a producer who would sell to the K amount of consumers. And in this case, you would earn the price of the product times the K consumers that buy it, and each of them would lose, the individual price of the product. So given that you get a Poisson coming out as a 1 or a 2 or whatever, you will be making good money that cycle. We have the array, which is just where all the data is kept. Everyone's like IDs, just from 0 to 999, their incomes, their wealth, their expenses, and whatnot. Then we have the taxes, which is derived from the US government website. And the last thing would be the expense rate. The expense rate is just the rate at which we want living costs to go up. Living costs are started at the 1989 poverty line. So the expense rate is just a number between 0 and 1 that takes the expense rate from 1 year, this, and turns it into the expense rate of the next year, like such. So if the expense rate was 1, then the expense rate would, double every year. If it was 0, the expense rate will become the same. If it was 0.1, the expense rate will increase by 10%, and so on. There is one more factor that is just not included into the function because it is normally distributed, so it does not need user input. L is a 100 data point long list of normally distributed points with mean 0.5 and standard deviation 0.12. These are just the numbers necessary to have a normally distributed probability. And then, just assuming this is representative of an infinite point normal distribution, we take 1,000 points out of there with true replacement, and we assign those to be the luck variables of each individual. If they are very lucky, i.e. 2 standard deviations above, so greater than 0.74, then their paycheck, their income, their payments, which I denote with this, will increase by their payment from last year, and then proportional to how rare their p-value is. Same thing if they're very unlucky, i.e. 2 standard deviations below the mean, right? Then their paycheck will decrease by an amount proportional to their unluckiness, right? So then the average person that gets really lucky or unlucky will actually increase their payment by 5%, because the average lucky person increases their payment by 18% and the average unlucky person decreases their payment by 13%. These numbers were made not equal so that the population overall would increment their incomes. We don't want to be a regressive population here. And this, I believe, is sufficient to understand the model.